The universe is not still. It is rushing outward, a tide of galaxies carried on an invisible current. Yet this expansion, relentless and accelerating, is not infinite in what it grants us. It is infinite in what it takes away. Stars fade, galaxies dissolve, horizons retreat. One by one, the lights of the cosmos slip beyond reach, vanishing not in explosions, but in silence. Their photons, once destined for us, are stretched away, carried faster than light by the swelling fabric of space. They will never arrive. Their stories will never be heard. This boundary, the cosmic horizon, is the edge of what can be known. Beyond it, the universe continues, but its pulse no longer reaches us. It is the faint heartbeat of visibility, itself fading with time, a dying signal at the border between the seen and the unseen. And yet, if the cosmos is infinite, why does it appear to shrink? If space expands without end, why does the horizon recede from us like a retreating tide? Is the universe erasing itself, or only hiding its vastness behind a veil we cannot pierce? Physicists describe this as more than a limit of sight. It is a limit of truth. The horizon does not simply conceal galaxies. It conceals knowledge itself. What lies beyond it may exist forever, yet for us, it is already gone. This is the mystery of the dying pulse of the infinite horizon, the fading boundary of a universe that erases its own light, even as it expands into eternity. What does this silence mean for the future of physics, and for our fragile place within a cosmos retreating into darkness? At the dawn of the 20th century, the cosmos seemed eternal. The stars were thought to be fixed, their light shining unchanged for all of time. Space itself was a quiet stage, infinite and absolute, upon which matter moved but never altered. The fabric of the stage itself. It was a vision of permanence, a universe without horizon, without edge, without pulse. Then came Albert Einstein. In 1915, with the publication of General Relativity, he shattered the static universe. Gravity, he showed, was not a force acting at a distance, but the curvature of space-time itself. And with this realization came a startling consequence. The universe was not a motionless stage. It was dynamic. It could expand, contract, bend, and evolve. The mathematics of relativity revealed something strange: horizons, regions of space, from which no information could reach an observer. Einstein himself did not yet imagine the cosmic horizon as we know it, but his equations carried its seeds. Out of relativity would grow the concept of the black hole, with its event horizon, the ultimate boundary of knowledge, beyond which events were forever hidden. In the 1920s, Edwin Hubble took the first step toward a cosmic horizon of a different kind. From the mountaintop at Mount Wilson, he measured the redshifts of distant galaxies, comparing them to their distances. The result was astonishing. The farther away a galaxy lay, the faster it retreated. The universe was expanding. The night sky was not static. It was stretching. This discovery introduced the first realization of an observable universe. If galaxies recede faster with distance, then beyond a certain point, their light can never reach us. Space expands too quickly, carrying them away faster than photons can cross the gulf. The observable universe is finite, bounded by the speed of light and the age of time itself. The cosmic horizon was no longer a philosophical abstraction. It was real. In the decades that followed, the horizon became central to the deepest debates in cosmology. In the mid-20th century, two competing visions of the universe clashed: the steady-state theory and the Big Bang. In the steady-state model, The universe expanded but remained unchanging, with new matter continuously created to maintain constant density. In the Big Bang, the universe had a fiery beginning, with expansion emerging from a singular event. The existence of horizons and their implications for the early universe became a crucial test. By the 1960s, evidence was mounting. The discovery of the cosmic microwave background by Arno Penzias and Robert Wilson confirmed the Big Bang. The background radiation was the fossil glow of an early horizon, the moment when the universe became transparent to light. The cosmic horizon was no longer only about what we see today. It was written into the very birth of the cosmos. Meanwhile, in the realm of black holes, Stephen Hawking was extending the logic of horizons. He showed that event horizons are not silent. They radiate faintly, a consequence of quantum mechanics at the edge of spacetime. This revelation linked horizons to thermodynamics, entropy, and the fundamental laws of information. If horizons radiate, then they also have temperature, entropy, and possibly memory. Knowledge, once thought lost beyond an event horizon, might not vanish entirely. Here a profound connection emerged. The cosmic horizon and the black hole horizon were kin. Both were boundaries beyond which information cannot return. Both were shaped by relativity, tempered by quantum theory. Both raised the same question. When horizons erase sight, do they also erase truth? The cosmic horizon thus transformed from a distant abstraction into a living frontier of physics. It was no longer simply a measure of distance. It was a measure of knowledge, a boundary written into spacetime itself. From Einstein's equations, Hubble's galaxies, Hawking's radiation, and the glow of the microwave sky, the picture grew sharper. We were not in an infinite, static universe, open to all that exists. We were enclosed within a horizon, a bubble defined by time and light, forever limited in what we could know. It was the first pulse of realization that the cosmos, vast as it is, carries boundaries, that horizons are not just edges of sight, but the architecture of reality, and that as the universe evolves, so too does the horizon itself. For most of the 20th century, the story of cosmic expansion seemed simple enough. The universe had begun in fire, it was expanding, and gravity, the great sculptor of structure, would determine its fate. Galaxies, drawn by their mutual attraction, might one day halt the expansion and pull everything back in a cataclysmic collapse. The Big Crunch, or, if expansion carried too much momentum, the universe would drift outward forever, gradually slowing but never reversing. The horizon, in this vision, was fixed by destiny, either temporary or eternal, but always logical. Then came 1998. Astronomers studying distant type Ia supernova, standard candles scattered across the deep universe, expected to find a slowdown, the tug of gravity etched into cosmic light. Instead, they found the opposite. The supernova were dimmer than predicted. The expansion was not decelerating. It was accelerating. The shock was immediate, paradigm-shattering. Something unknown, later named dark energy, was driving galaxies apart faster and faster. The cosmic horizon was no longer static. It was receding at superluminal speed, pulling regions of the universe beyond our eternal reach. Every second, more galaxies slipped away, not because of motion through space, but because space itself was swelling between us. This meant that most galaxies, the vast majority of the universe, would eventually vanish from the observable cosmos. Their light, already en route, would continue to arrive for billions of years. But beyond a certain threshold, no new photons would ever reach us. They would fall behind the cosmic event horizon, swallowed not by black holes, but by the accelerating fabric of space-time itself. The philosophical weight was profound. Humanity had once imagined the universe infinite and knowable. Now, the discovery suggested that the visible universe is shrinking in relative terms. Not because it is collapsing, but because expansion erases connection. Every moment, cosmic history is cut away. The horizon is a dying pulse, fading with time. This expansion carried thermodynamic consequences as well. In a universe dominated by dark energy, the cosmic horizon behaves like a black hole horizon. It has an associated temperature, unimaginably small, but real, and an entropy proportional to its area. The horizon itself radiates faintly, like a memory dissolving into silence. Here arose the deepest paradox. If information disappears beyond the horizon, is it truly lost, or is it encoded somehow, holographically, on the horizon's surface? This mirrored the black hole information paradox that haunted Hawking and others. When something falls into a black hole, does its information vanish forever, violating quantum laws? If the universe itself has a horizon, the same riddle expands to a cosmic scale. The implications were terrifying. Not only do stars die, not only do galaxies fade, even horizons themselves carry death, erasing visibility, erasing connection, perhaps even erasing knowledge. Physicists struggled to absorb the revelation. The steady-state model had collapsed decades earlier. Now, even the Big Crunch was cast into doubt. Instead, the cosmos seemed fated for a lonely future, galaxies racing away, horizons shrinking in reach, the night sky emptying into silence. The shock was not only scientific but existential. To live in an accelerating universe is to live in a cosmos that is erasing itself before our eyes. The cosmic horizon is not a passive limit. It is active, dynamic, a boundary that grows as light fails to keep pace. It is the dying heartbeat of what can be known. And so, from the flicker of distant supernova, a new truth emerged. The universe is not merely expanding, it is isolating. The infinite horizon has a pulse, and that pulse is fading. The revelation of accelerating expansion demanded more than astonishment. It demanded proof. If the horizon was receding, if galaxies were slipping away forever, then the evidence had to be written into the oldest light of all, the cosmic microwave. Background: this afterglow of the Big Bang had already transformed cosmology. It showed that the early universe was astonishingly smooth, with faint ripples seeding the galaxies of today. But it could also reveal the geometry of the cosmos, the shape of space itself, and the destiny of horizons in the early 2000s. The Wilkinson Microwave Anisotropy Probe, WMAP, mapped the background with unprecedented precision. Its data revealed that the universe was flat to extraordinary accuracy, balanced on a razor's edge between open and closed. This flatness was consistent with a cosmos dominated not by matter, but by a mysterious energy driving eternal expansion. The forgotten pulse of the horizon was already written in the sky. Then came Planck, launched in 2009 by the European Space Agency. With its exquisite resolution, Planck painted the most detailed portrait of the early universe ever seen. Within its subtle ripples lay confirmation. Dark energy dominated. Horizons were real, and the fate of galaxies was sealed. The horizon was no longer an abstraction. It became twofold. The particle horizon marked the distance light has traveled since the Big Bang, the limit of what we can see today. But beyond it lay the cosmological event horizon, the ultimate limit of what can ever be seen, no matter how long we wait. The difference is subtle, but profound. One is the record of the past. The other is the boundary of the future. Mathematical studies of de Sitter space, the geometry of a universe ruled by dark energy, deepened the paradox. In such a cosmos, horizons are permanent. They radiate with faint thermal energy, like black holes. They carry entropy, information, and perhaps memory. If the universe is heading toward eternal de Sitter expansion, then the horizon itself is the final stage. A silent wall, infinite yet enclosing, against which all knowledge crashes and dissolves. Patterns at the scale of the horizon also began to puzzle cosmologists. Alignments in the CMB, strange correlations of temperature fluctuations across vast angles, hinted at anomalies. Some called it the axis of evil, a preferred direction in what should have been a random, isotropic sky. Could these patterns be statistical flukes, or were they whispers of physics beyond the standard model written into the horizon itself? The deeper the investigation, the more horizons revealed themselves, not as edges of perception, but as properties of reality. They were dynamic, thermodynamic, quantum. They connected the fate of galaxies with the fate of information. They linked the expansion of the universe to the entropy of space-time itself, as supernova surveys expanded, as baryon acoustic oscillations traced the ripples of structure across billions of light-years. The evidence converged. Dark energy was real. The horizon was accelerating, and every second, more of the cosmos was slipping away. The growing realization was unsettling. The horizon is not simply a limit of vision. It is the architecture of space-time, the stage upon which physics itself is written. It is a dying pulse, and as it fades, it carries with it not only light, but the memory of existence. With every new measurement, the universe revealed itself to be stranger than expected. What began as the discovery of an expanding cosmos had become a story of acceleration, of horizons receding beyond reach, of light erased before it could ever arrive. Yet as the evidence grew, so too did the weight of its implications. The horizon was not only real, it was dying. Every second, new galaxies cross the event horizon of our observable universe. Their light, though once aimed toward us, will never complete its journey. What we see today is only their ancient glow, billions of years old, while their present and future drift forever beyond contact. The universe is not simply vast, it is vanishing before our eyes. Physicists calculate that, in 100 billion years, the night sky will be emptied of everything but the local group, the Milky Way, Andromeda, and their satellites, bound together by gravity. Beyond this small island, the rest of the cosmos will be erased from view. Future astronomers, if any exist, will look outward and see only silence. They may never even know a larger universe once existed. This vision is staggering. Not only stars and galaxies die, but horizons themselves retreat, severing the threads of connection that bind us to the infinite. The cosmos, expansive and eternal, is also erasing its own history. Every heartbeat of expansion is also a heartbeat of loss. Theoretical puzzles magnify the dread. If information passes beyond the cosmic horizon, is it destroyed? Quantum theory insists that information is never lost. Yet relativity describes horizons as one-way barriers. This contradiction is the information paradox, first posed in the context of black holes, now expanded to the universe itself. If the horizon erases truth, does it violate the laws of physics? Or is every event preserved, encoded somehow on the horizon's surface, written into space-time like a cosmic hologram? Such speculation deepens the crisis. If information is preserved, then the horizon is not a void but a membrane, carrying the memory of everything that has ever crossed it. If it is not preserved, then physics itself may collapse, its laws unable to withstand the silence of eternity, and the future grows darker still. If dark energy strengthens, the expansion may accelerate into catastrophe. The big rip in this scenario, not only galaxies, but stars, planets, molecules, even atoms are torn apart as space expands without bound. Horizons would not only retreat, they would collapse entirely, shredding space-time itself into incoherence. Time, distance, and causality would die in a final convulsion. Even if such a fate never comes, the existential weight remains. To live in an accelerating universe is to live in a cosmos that erases its own past and its own future. The horizon is a pulse that fades with time, and as it does, it diminishes not only what we can see, but what we can know. For humanity, the realization is profound. The universe is not an infinite library open to all readers. It is a book that erases its pages as it is read, a manuscript dissolving line by line. Each galaxy that slips beyond the horizon is a chapter lost, a story forever silenced. Here, science collides with philosophy. What does it mean to exist in a universe that hides itself? If the horizon is infinite, why does it appear to shrink? If reality stretches endlessly, why does knowledge collapse? The cosmos grows, yet our access to it diminishes. The paradox is unbearable. Infinity expanding, yet horizons dying. The dying pulse of the infinite horizon is not merely a scientific curiosity. It is an existential riddle, a reminder that we inhabit not a timeless stage, but a fragile island of visibility in a sea of vanishing light. The dying pulse of the horizon is not only an observation, it is a question posed to physics itself, a riddle without resolution. What is driving the acceleration of the universe? What is the true nature of horizons? And what fate awaits a cosmos in which galaxies vanish beyond reach? The most conservative answer lies in Einstein's own equations. When he first formulated general relativity, he introduced a term known as the cosmological constant, a repulsive energy embedded in space-time, balancing gravity to preserve a static universe. He later called it his greatest blunder. Yet decades after his death, the constant returned, no longer as a mistake, but as a possible truth. Perhaps dark energy is nothing more than this cosmological constant, an intrinsic property of space itself, unchanging, eternal. In such a universe, the horizon stabilizes into a de sitter state, its pulse fading but never extinguished, its boundary permanent. But many physicists are not satisfied with this simplicity. They imagine instead that dark energy is not constant, but dynamic, a field that evolves with time. This hypothesis is known as quintessence. If quintessence weakens, expansion may slow, perhaps even reverse into collapse. If it strengthens, acceleration may accelerate still further, tightening the horizon until galaxies, stars, and atoms themselves are shredded in the catastrophic Big Rip. In this vision, the dying pulse is not a fading heartbeat, but a death throe, tearing space-time apart. Others push speculation even further. The thermodynamic properties of horizons suggest they may not be boundaries of ignorance, but repositories of information. Here enters the holographic principle, the idea that the universe is not three-dimensional as it appears, but a projection with all its information encoded on a two-dimensional boundary. Just as black hole entropy is proportional to horizon area, so too might the cosmic horizon carry the imprint of everything within it. In this view, the dying pulse of the infinite horizon is not information lost, but information compressed, written on the fabric of the boundary itself. This speculation raises still deeper questions. If the universe is holographic, then what we perceive as reality, galaxies, stars, even time itself, may be emergent phenomena, shadows of information inscribed on horizons. The pulse of the horizon, then, is not only the fading of visibility, it is the rhythm of reality itself, the beat by which existence is projected into experience. Other theories stretch beyond even this. In some models of phantom energy, dark energy grows so powerful that it not only accelerates expansion, but destabilizes space-time itself. The ultimate singularity is not collapse, but disintegration, the annihilation of all bonds, the rupture of causality, the erasure of the horizon, into chaos. In this cosmos, the dying pulse is not gradual. It ends in a violent crescendo, a final rupture. Still others invoke the multiverse. If inflation, the rapid expansion that smoothed the early universe, continues eternally in distant regions, then our observable cosmos is only one bubble in an infinite foam. In such a vision, the cosmic horizon is not the edge of everything, but only the edge of us. Beyond it, other universes may swell, infinite and unseen. The dying pulse of our horizon, then, is not the death of all horizons, but the silence of a single world among countless others. Speculation even touches on the possibility that horizons are portals, transitions rather than endings. If information is preserved holographically, could the retreating horizon represent not loss, but transformation? Could it signal the flow of reality into another domain, dimensions we cannot touch, but which may carry the memory of what is erased from our sky? Each theory offers an explanation, but none resolve the paradox. A cosmological constant explains acceleration, but cannot justify its scale. Quintessence introduces dynamism, but at the cost of new unknowns. Phantom energy leads to catastrophic endings, but with little observational support. Holography suggests preservation, but forces us to abandon ordinary notions of reality. The multiverse multiplies possibilities, but dissolves prediction into infinity. The dying pulse of the infinite horizon remains a riddle, because every explanation carries more mystery than it resolves. Theories expand like the cosmos itself, branching, accelerating, receding, and yet all are bound by the same fact. The horizon is real, it is receding, and with it vanishes the visible universe. Here, science edges into philosophy. If horizons preserve information, then nothing is truly lost. Every event, every star, every life remains inscribed in space-time. If they do not, then existence is more fragile than we imagine, with truths erased forever beyond recovery. Either outcome reshapes our understanding of reality. In the end, the theories converge not on certainty, but on awe. Whether dark energy is constant, dynamic, or catastrophic. Whether the horizon encodes memory or annihilates it. Whether the multiverse exists or not, the horizon remains the fading heartbeat of an infinite cosmos. Its dying pulse is both scientific puzzle and existential mirror. To understand the dying pulse of the infinite horizon is not merely a philosophical endeavor. It is a scientific pursuit measured in telescopes, satellites, detectors, and supercomputers. The universe hides its secrets in faint signals, and only the most delicate instruments can draw them out. Humanity, a fragile species bound to a small world, has built machines that stretch vision across time itself, attempting to grasp the horizon before it slips away. The first tools were telescopes that mapped galaxies, measuring their redshifts and distances. Hubble, with its deep fields, revealed the tapestry of the cosmos receding into silence. Every faint speck of light was a galaxy, some billions of years old, whispering of horizons long vanished. The telescope that bore the name of the man who discovered cosmic expansion became the first great eye on the pulse of the horizon. Now, new instruments carry this legacy forward. The James Webb Space Telescope, with its golden mirrors, peers further back in time than ever before, capturing galaxies from the first few 100 million years after the Big Bang. Each observation tests the rate of expansion, the behavior of dark energy, the shifting edge of the horizon. Webb is not only an observatory of stars, it is a sentinel of the horizon's retreat. On Earth, vast instruments chart the distribution of galaxies across billions of light years. The Vera Rubin Observatory prepares to map the sky in unprecedented detail, tracking how galaxies cluster, how voids spread, how expansion accelerates. Its survey will create a time-lapse of cosmic motion, a cinematic record of the horizon's fading heartbeat. But light alone cannot tell the full story. The cosmic microwave background, the relic radiation of the early universe, remains the most precise map of horizon-scale physics. Missions like Planck, the Atacama Cosmology Telescope, and the South Pole Telescope probe its polarization, searching for signatures of primordial gravitational waves, echoes of inflation written at the horizon of time. Future missions like Light Bayard and CMBs aim to detect these signals with unmatched sensitivity. If found, they would confirm that horizons were not only present at the beginning, but that their pulse shaped the very birth of the cosmos. Beyond photons, other messengers deepen the search. Gravitational wave observatories, such as LIGO and Virgo, listen to the ripples of space-time. Though built to capture the collisions of black holes and neutron stars, their successors may probe signals on cosmic scales, testing whether the large-scale geometry of space-time conforms to de Sitter expansion. The horizon may speak not in light, but in the trembling of space-time itself. At the smallest scales, particle physics seeks answers. The Large Hadron Collider and dark matter experiments probe fields and forces that may underlie dark energy. Could an undiscovered particle or field drive the expansion? Could quintessence be revealed in the laboratory? Each collision is a microscopic reflection of cosmic fate, a search for the source of the dying pulse. Supercomputers knit these observations into models, simulating billions of years of cosmic history. They track the growth of structure, the acceleration of expansion, the entropy of horizons. Within their digital universes, physicists test scenarios, a cosmological constant, quintessence, phantom energy, holographic boundaries. Each run attempts to match the sky we see and the horizon we cannot, and still questions persist. Can science ever measure the end or the non-end of time? Can instruments truly capture what lies beyond the horizon? Or are we forever confined to inference, deducing from fading signals what the universe is erasing? Yet, even within limits, progress continues. Each photon counted, each wave detected, each model refined brings humanity closer to understanding. The horizon may be infinite, but its pulse is recorded in the faintest traces. Science listens patiently to the dying heartbeat of visibility. The universe is vast, yet it is not boundless to us. It offers its secrets sparingly within the confines of a horizon that ebbs away with every passing moment. The science is rigorous, the mathematics precise, yet beneath these truths lies a deeper weight, the philosophy of loss. The dying pulse of the infinite horizon is not only a cosmic riddle, it is a mirror in which humanity glimpses its own fragility. Every galaxy that slips beyond reach is more than a cluster of stars. It is a story extinguished from the narrative we can ever tell. Their light, once faithful, will cease to arrive. Their histories, their futures, will unfold in silence. The horizon is a cosmic eraser, not of reality itself, but of our access to it. In this sense, the universe is not simply expanding, it is forgetting, and what of memory? If horizons truly preserve information holographically, then nothing is lost. Every star, every orbit, every flicker of light is inscribed upon the boundary, eternal though inaccessible. If not, then truths vanish, irretrievable, and the cosmos becomes an ocean of absence. Humanity must confront this uncertainty to live. In a universe where knowledge itself may be erased, the loneliness of the far future is staggering. Imagine skies emptied of galaxies, constellations faded into obscurity, the cosmic web erased from view. Civilizations born in that era may never know the grandeur of the expanding universe. To them, reality will appear small, isolated, local. The dying pulse will have already silenced the chorus of creation, and yet there is humility in this vision. For the horizon is not merely a boundary of sight, it is the architecture of existence. To live within it is to be part of a larger whole. Even if much of that whole remains unseen, the horizon defines us not by what we can reach, but by what we cannot. It reminds us that knowledge is bounded, that wonder thrives within limits. Philosophers once asked whether time itself could end. Scientists now ask whether information can vanish. Both questions converge on the same truth. The universe is finite in what it reveals. Its pulse may fade, but in its silence, it teaches the meaning of perspective. For humanity, the lesson is profound. We are small, transient, bound to a vanishing horizon, yet in our fleeting moment, we have seen far. We have built instruments that stretch vision to the edge of time, heard whispers of creation in microwave static, and measured the retreat of galaxies across the abyss. The cosmos erases, but we record. The horizon fades, but we remember. Perhaps meaning lies not in the permanence of knowledge, but in its pursuit. The dying pulse reminds us that to seek is itself significant, even if the universe hides more than it reveals. We are sparks in the cathedral of space-time, illuminating fragments before darkness returns. And so the closing image emerges, the universe, vast and eternal, its galaxies drifting away, its horizons fading into silence. No sound marks their departure, only the stillness of light extinguished at the edge of reach. Yet the river of time flows on, indifferent, unending. The horizon's pulse weakens, but its rhythm remains the heartbeat of reality. In this silence, humanity listens, not to conquer infinity, but to understand its whisper. The dying pulse of the infinite horizon is a mystery unsolved, perhaps unsolvable, but within it lies the essence of existence. to be finite beings in an infinite expanse, to carry questions that outlast answers, to live in a universe that both reveals and conceals, endlessly, beautifully, forever.